Our last speaker in this section is Dries Verbruggen. I'm not sure if I'm saying it right, who founded Unfold Studio in 2002 with his life and work partner Claire. They are a design office that explore how new technologies fit within the tradition of making. Dries is going to be talking about reclaiming control.
There's a second part. Yeah, so that's me and Claire. Claire hiding her pregnant belly behind a piece of cardboard. Because I'm just going to focus on one strand in our practice. I like to just start with this quote that I think sums up quite a bit of our autonomous work. We have a autonomous practice, and then we have client work, and also a bit of teaching. But a lot of our projects explore this kind of intersection, this world in between digital making and traditional modes of making. And we're mostly interested in all these kind of tangents that cross through that intersecting field. And we're interested in all these aspects that come with it. Things like authorship, for example, with Kiosk, a project we did in 2011, I believe, in which we tried to investigate what happens if digital manufacturing, digital production machines end up on the street corner, and what happens with the world of design and manufacturers if the street starts to appropriate design in ways that we see the YouTube generation currently appropriating film and music. And projects, for example, that were best known, I think, maybe also in this audience, for example, l'artisan électronique, which is somehow a 21st century take on a traditional potter's studio. So on one hand of the installation, you have this digital pottery wheel where visitors to the space can literally push their hand in the physical matter and start, or in the digital matter, and start to shape a digital pot. Which is then connected to a device that we started developing in 2009, which is a 3D printer that works with ceramic instead of with plastic. Okay, so the title of today, Riding on the Edge of Control, about reclaiming and relinquishing control. And that's very important for me, that last part. Typically, the last years, I stopped doing it, but I would start with this slide and a set of slides that our work is mostly dealing with this kind of identity crisis. What is our role? We're trained, both Claire and I, as industrial designers. What is that identity? Where does the industrial designer come from? And if you look at that history, of course, the grandmother or grandfather of the industrial designer was the craftsman, who had this total kind of holistic practice where making, financing, distribution was all kind of tied up in this one profession. And that kind of, with the advent of the Industrial Revolution, lots of those responsibilities were stripped. Manufacturing went to the factory floor, finance went to someone called manager, or what do they do? There was marketing, and all these kind of gatekeepers started to surround the designer. And designer was only responsible for making the drawing. And one of the things that led to is this kind of fetishism over detail, I think, kind of putting all that control and all that responsibility on top of that exact chamfer milled in the aluminium edge of the iPhone, this or that, that you hear Johnny Ive talking about. And today we see this kind of, what is it? A kind of a new role for design, a new role for the designer that kind of merges pre-industrial craft methods with industrial machinery. And a lot of that is, call it the post-industrial designer or the maker, and a lot of that is actually made possible by digital technology. So we can reclaim a lot of that lost territory and start to, again, using things like Kickstarter, start to finance your own work. Everybody can build a website and promote their own work. And with digital manufacturing, we see this kind of tools also coming back to the individual studio. And so with manufacturing going digital, we see this merging of these aspects of pre-industrial craft economy with high-tech industrial production tools. And that has a combination, has the potential to shift this power from larger industrial producers and infrastructures to the individual designer and consumer. So it reverses the blow of industry versus the craftsman and brings back this industrial machinery to the small-scale studio. That's a bit about reclaiming. So for us, it was always a bit about reclaiming those different fields and doing experiments with financing and distribution and production and manufacturing and creating tools. Like in L'Artisan Électronique, you see a lot of these things coming together. And often from a craft background, from a traditional pottery, it would seem like we make a two-button Guitar Hero version of pottery, right? You make this very nice tactile thing and you turn it into two buttons and some lasers. But for us, we came from this other side. We were interested in making technology dirty again, making it hands-on, making it direct, making it kind of almost, if you could, literally push your hands in the digital matter. But it's also about relinquishing control. And in the last year, that has been growing so much on us because kind of reclaiming control didn't describe a lot of what we did. And maybe a good project to illustrate that sits a bit on this intersection between reclaiming and relinquishing control is Stratigraphic Manufactory. So when we developed ceramic 3D printing in 2009, we immediately open sourced all the tools and all the methods, and we threw it all online. And there was basically, I think, 5 people following all of that. And that kind of grew. This, for example, Jonathan Keep, he was really one of the first trained as a traditional potter to kind of appropriate and really build on top of what we did and extend it and remix it and really turn it into kind of his own thing. And together today we are running the Make Your Own Ceramic 3D Printing community on Google+. And the last time I took this snapshot, 1,400 members. Today it's over 2,000. And that's not, even though the title is clearly about ceramic and 3D printing, that's not all kind of craft or making-oriented people. There's actually lots of scientists lurking in corners. And I was very happy that in one of Carol's pictures, I actually spotted one of my extruder designs that I always thought was a hopelessly failed design, but then somebody is actually using it successfully. I'm no mechanical engineer, so I always did it out of a pure kind of frustration and need. I wanted to develop this tool. But yeah, and lots of the tools we've developed are being used also in bioprinting, and in other experimental 3D printing techniques, for example, printing silicones and conductive materials. So there's lots of people gathering there together. But for us, it's also kind of a source of inspiration and a source of material. So this is also kind of an old map of all these local ceramic 3D printing facilities around the world. So these are people who built their ceramic 3D printer and who can run it, who can work with it. And we thought, okay, what if we connect these all together and turn it into a factory? So instead of classical centralized mass manufacturing where you produce everything in one spot and then you ship it around the world, what if we just connect all these places together? And I think it was Adrian Boyer who said it's easier to ship recipes than it is to ship cakes. So we use digital files, we send them around, and then those are produced locally. And it's not distributed manufacturing is not a new thing. Of course, it's very connected to the realm of 3D printing. But if you look at a company like, for example, Shapeways, where you can send your file and then based on where you are, they'll print it in Eindhoven, the Netherlands, or in New York. We thought that's, and they do it on the exact same machines, exact same specs, and the exact same things should roll out. But we thought that's kind of a old-fashioned idea of mass manufacturing of industry where every single item should be exactly the same. So we thought it would be more interesting if you could allow that local vernacular into the actual production. So we sent That was 2012. We sent around to those actual 12 people who could do it at that time. We sent the same set of digital files. We asked them not to alter the digital design, but in the physical making, they were completely free to do it the way they want. So using localized material or glazes. What's nice about clay, it's so local, but all different types of clay also shrink differently. So you get all these little size variations, different ways of slicing it, very thick or very thin. And then there's, of course, also the kind of the skill of the maker who maintains his machine, who mends his machine, who prepares the clay, who is more skilled or less skilled in glazing, etc. So this Jonathan Keeps. Set with a porcelain and a celadon glaze. And then we were also traveling around, exhibiting it as a museum project that often happens with our work, and working with each time local ceramists that we would give like a one-day boot camp training in ceramic 3D printing. And then they would make copies of our design, or what we call just variations, iterations. And this, for example, Mustafa Kanyurt in Istanbul, and you see this completely different sense of aesthetics. He way much more appreciates also where the process takes over from the kind of rigid digital model. So you have this more earthen terracotta with a very thick glaze on the inside and a much kind of more process and clay going a bit, doing weird and odd stuff. And you have all these kind of variations in the output. We nourish kind of failures that are on the edge, because sometimes it becomes a feature. This is from the group that we worked with in Taiwan. So you see, again, like completely different, something that has become quite a standard in ceramic 3D printing, what I call the Toothpaste Technique. So you have two colors of clay coming out the same nozzle, and they create all these kind of interesting patterns. And also talking about craft and what is craft, and sometimes I get a question from the audience and it says something along the lines of, if it's not touched by the hand, it lacks soul. Of course, I haven't seen any glass blower touching hot glass, so there's always is there a tool, and of course that definition of what a tool is malleable and stretches. And I like this quote by, if you're interested in this field, Abstracting Craft by Malcolm McCullough. I really like it because it's a bit dated, and he talks about the future, which is basically today, and that's nice. But the work of craft is neither the design nor the individual artifact. It is the tradition of the very production. It is the presence of many objects identical in their conception and interchangeable in their use, but unique in their execution. Craft implies working at a personal scale, acting locally in reaction to anonymous globalized industrial production. So even though we are using machines from the industry, things that people often see now today as what is going to replace all jobs, 3D printing, all jobs and all handmade stuff. And you see that it actually nicely slots into this definition. It just depends how you rig it all together. Yeah, so like I explained, it was mostly a kind of speculative design, hypothetical scenario. People actually asked how we get that sign on top of the new museum in New York. That's Photoshop, the wonders of the digital age. So we've been to London, New York, Yingge in Taiwan, Korea as well. It's nice to see all these different kind of approaches towards ceramics around the world. So mostly hypothetical, but at the same time, last week or a few weeks back, I just had an order to print, and we regularly, in general, we don't do this, but we had an order to print 400 cups, and we did it. And by sheer coincidence, 2 weeks later, we got an order of 1,200 cups. And that was way beyond what we could do. But we have this network, so we tapped into this network. And in this is a photograph from Vormvrij in the Netherlands, which is also, who are a very active member of our community and who market 3D printers specifically for printing ceramics. So they put 4 of their machines next to each other and started running this production. So for us, it really, this kind of open sourcing something is, in essence, like relinquishing control. You throw it out, you're not claiming any IP or anything, but there's indirectly so much that comes back to you as a small-scale design and creation studio. Another project that comes directly out of that community is the Transaction project, initiated by Charlie Stern and us, and in collaboration with lots of other people. And that's what you see in a lot of our projects. It becomes, now I'm using et al. Because the list becomes so long after a while that, but much of our projects are collaboration. And this one was centered around this idea that Charlie had: can we use the ceramic 3D printing as a mold making technique? The Romans blew glass in terracotta molds, and yeah, video works. And so he thought, okay, can we use that to preserve historical shapes? So we have a digital scan of a historical shape, we print it in ceramic, blow it, ceramic breaks, and we have the glass object. And we did first a residency at Konstfack in Sweden, and quickly we figured out that we could actually blow in it without breaking. And we thought it was a bit of a shame to go through this elaborate process and then always lose the ceramic. So we started to experiment with methods to keep the ceramic and glass as one piece. And glass and ceramic compatibility is kind of a topic, because they're so similar, being high in silica content, but also so different in the sense that glass shrinks differently when it cools down, ceramic shrinks when you heat it up, etc. So there's all this kind of on the edge of being compatible and non-compatible. So we came to a point where we can actually put it back in the glory hole, and the whole ceramic withstands the heat shock. And again, what was nice about 3D printing is this very craft-like iterative process. You know, every Stradivarius violin was actually the prototype of the next one. You know, there was no product and prototype distinction. Everything is a prototype for the next one. So what we did is we set up inside of the glass studio. We would be printing. So first in the morning, glass blowing, afternoon, night, printing, and then we would dry everything on the glass kilns, and and fire it the next day, and then blow again. So we had this very rapid, iterative development process, because we figured out quite quickly that the geometry of the ceramics, together with the composition, was quite essential in the survival rate of that. And then we started to, because the title Transaction project, for us it was more about being conductors. We did not really design any of those pieces. We worked with glass blowers around the world, with different ceramic 3D printers, the people, not the machines, to create different pieces, and then with glass blowers to interpret those pieces. And I heard it multiple times today, but that conversation is it takes some time. A glass blower, and you introduce yourself as a designer, and they already go like, whoop, okay, designer, eye shades on. They hate designers. Because they think of a designer as this person coming with this A4 drawing made in Rhino with tolerances of 0.1 millimeter, and that's not what glass blowing is. So when we tell them like, you can make your own interpretation, they're like, oh, that's suspicious. So it took some time. So this again in Korea. So here you see all the credits. This is one range that we made literally, in which I think I designed only one shape. So we see ourselves more as making the framework, supporting and keeping that whole community fueled and alive, maintaining it, doing the boring things, doing the exciting things as well. But and that's how we more see kind of our role as designers, not kind of holding on to that exact responsibility of the final object, but more as kind of agitating systems and structures and making tools. The last one, quickly, Scafaldo, which is literally kind of dealing with control as a design method, or the lack of control. We were invited to do, for the Milan Fair, a collaboration with a Belgian company, and we choose Materialize, which is one of the biggest in the world 3D print manufacturing service suppliers. And for most people, that was like, yeah, of course, Unfold works with Materialize, very obvious. But for us, it was really like a new thing, because we have always been doing everything ourselves because we hated having to work with a 3D, a large industrial 3D printer. So we built it ourselves in 2009. So it was kind of something to try and work with this kind of bigger system that's outside of our own studio. And Materialize is quite known for doing lots of prints and things for big artists and designers and medical and industry, car manufacturers, etc. But what most people don't know is that in essence they're a software provider. So they develop the algorithms and the software tools that a lot of the 3D print service providers run on. And what we wanted to do is kind of emphasize that software and work with this algorithm that they produce, this piece of software called eStage, which is really the black sheep in 3D printing. It generates support structures. So if you print something in a resin printer, in this case, if you don't create support structure, it starts to float in this bath of liquid photosensitive polymer. So you need this structure to keep it in place and to support overhangs and stuff like that. And if you look at these structures, they're totally mesmerizing. They're like almost, I immediately had to think about this, like the work of Bernd and Hilla Berger, photographing Dutch industrial archaeology, this neo-Gothic, hyper-functional, but at the same time aesthetical structures. So this is exactly the same. It's really born out of necessity and efficiency and everything. Nobody ever made any decision in regards to aesthetics, like, because this ends up in the trash. After printing, it goes straight in the bin, unless we're around, because we kind of scavenge all these things. So we wanted to design with this process that is kind of hard to control. And it was really, this first piece is done in a very short time, and I think we made about 200 iterations of these designs. So what we did is design only the top part and then send it to Materialize, and then they would generate the support structure. And each time I thought, like, now I know exactly what's going to come out. And each time it was a surprise, it was different. Because it takes into account so many parameters, the age of the resin, the orientation in the machine. All these things play a part. So we had to figure out also ways of reproducing actually these pieces, so storing the actual data that we used to produce it. And then in the end we 3D printed only the support and not the actual parts that were used as, I call them seeds, to generate the structures. They're super brittle, they're made to break, they're made not to last. So we worked with Factum Arte in Madrid to cast them in bronze using centrifugal rotomolding. And then the actual 3D input pieces, the seeds, were reproduced in traditional, what I call traditional methods. So glass blowing, and the other piece is CNC milled. Some detail of the structures. We actually had to put some little kind of annoying objects sometimes floating in the middle to kind of frustrate the process. The last version of that is something we did last month. So I saw his picture already on Liam Reeves, the glass technician at RCA. So he has this very nice, in his own body of work, these very nice kind of organic shapes. So we were a bit frustrated with the previous pieces because we designed on the computer and then inputted into the process, the algorithms, and it felt a bit wrong. So we thought, okay, what if we just make something that you can't ever recreate? So it's very intuitively blown and twisted and it kind of distorts. Then we 3D scan it and let that generate the support structure. And these are the final pieces. So you have this kind of semi-random bubble that is supported by this small, it's really tiny actually, desk clamps, this kind of intricate support structure. Okay, to close with something completely unrelated, I think. Do you know what this is? This is the first computer bug. And now I have to look up the exact date. So that was 1947, Grace Murray Hopper, I believe they were working on not the atomic bomb, that was too late. But of course, these computers were developed for the atomic program, and they consisted of relays, switches. So it was a Mark II relay computer, and so first actual case of a bug, this animal was stuck in a switch, and of course the program couldn't run because of that bug being stuck in the switch. And what I like about this is that we forget when we look at things like this, iPad or iPhone or Android phone, that those hermetically closed aluminum boxes with CNC chamfers are actual pieces of technology that you can intervene with and that you can hack and that you can change. And we're often too afraid, I think, to do that these days. But these kind of examples show that that's really kind of physical machinery that moves switches and where a bug actually throws a mistake in the system. And that's my closing point. Thank you.